Hey guys, I'm doing this video because I know that all the seniors missed my G period class today, so I wanted to make sure that they had the lesson. So basically, this lesson takes what we've been doing with exponential growth and decay and just adds one tiny tweak to it. So before we even add that, let's say that we've got this situation A where Dan owes the bank $20,000 with 4% interest. How much will he owe the bank in 2 years? So this is a problem that we know how to do. We don't know A. We know that P is 20,000. Since interest is 4%, we'll add 0.04 to 1, and we'll raise it to the 2 power. So this is just a regular exponential growth problem. We throw that into a calculator, and we find out that at the end of 2 years, Dan's going to owe $21,632. We know how to do this, okay? So then the question is, does it make a difference if we spread that interest across each year and calculate 2% every 6 months? So let me explain what I mean here by that. Let's say we have the situation we just dealt with, where this is a year and this is a year. And we said that each year, that's going to be 4% interest, right? So what this means is we go through this whole year, we calculate 4%, then we take whatever we got, we go through this whole year, calculate 4%, and there it is at the end of 2 years. So my question is, what if instead of doing that, we still have 2 years, so these are still the same 2 years, but instead of calculating that interest at the end of the year, we cut it in half and calculate the interest twice per year by spreading that 4% out. So we'll do still 4% per year, but we're going to do 2% in the first half of the year and 2% in the second half of the year. And when you look at this, you think about it and you say, well, this is still 4% in a year, this is 4% in a year. It shouldn't matter how much we cut it up, it's still going to be 4%. So at the end of the year, or at the end of the 2 years, we should still have the same amount of money. So that's maybe our hypothesis, and now we're just going to try to test that. So what we're going to do is we are going to calculate how much money Dan owes every 6 months, at the end of each 6-month period. So the first 6-month period, let's say he has his $20,000 initially, and now it's only 2% for this first interval, right? Time is 1, because this is just one interval of 2%. So we calculate that, and we end up with $20,400, all right? Which means going into the second set of 6 months, that's how much money we have now, and we're going to add another 2% of interest onto that. So we put that in the calculator, and we get $20,808. So at the end of the first year, he owes $20,808. So we throw that money into the third set of 6 months, and after 18 months, now he owes $21,224.16. So we're going to use that, calculate our final 2%, and it turns out $21,648.64 is how much he owes at the end of that period of time. So we take a look at that and we say, if I compound the interest, then he's going to owe $21,648.64. If we don't compound the interest, he owes $21,632. So that's more money if we compound the interest. It's not a lot more money, but it is more, just a few bucks. So it seems like compounding the interest is better, and that's exactly what we find. So what we're going to do here is define compounding interest. So I'd like you to have this definition in your notes. Compounded interest just means that when they initially give the interest rate, it refers to an annual rate, so that's for the year. But we can spread that across an entire year and specify how many intervals we're chunking that year up into. So, for instance, I did say we'd do it every 6 months, which ended up being twice a year. But I could have cut this into fourths, right? Or or we could then cut it into eighths. We could have done any of those things. And one thing that we're hypothesizing now is that the more we compound our interest, it seems like the more money our account is going to end up being worth. And in this case, Dan's going to end up owing more money. So the one thing we want to change here now is the formula that we've been using. It's very similar to the current formula. But in this case, we've taken the rate, and you'll notice it used to be 4%, now it's 2%. So we've cut the rate in half, or we've divided it by some number where n is, how often we're cutting up that interest rate. And then something happens to the time as well. We're going to multiply the time by n because notice, once I cut up the interest rate, now I have 1, 2, 3, 4 intervals instead of just 2 intervals. So I have to multiply the time by whatever it is I divided my rate by. So in this formula, n is the number of times interest is compounded. So this is our new formula for exponential growth. Until today, basically we were just saying n is 1 every single time. We were saying compounding interest isn't a problem. We're just going to say we're compounding it once a year, done. But now we're going to start to see problems that involve a compound interest rate that is not 1. So what would Dan owe, we're down to C, if the interest was compounded quarterly? So we're trying to find out the total amount. We're still going to say he's got $20,000. Money grows, so 1 plus the rate, which is 0.04, but we're dividing that by how often we're compounding, and we're compounding quarterly here. So that means we're cutting the year up into fourths. So n is 4, which means I have to multiply my time by 4. And I'm going to throw that into a calculator. And I have $21,657.13, which you'll notice is even larger than what we had when we compounded it twice per year. So the last thing I'm going to do is over in this space, I'm just going to make a little table of some of the words that'll come up in these problems frequently that indicate that interest is compounding. So if the problem is talking about compounding interest annually, that's just going to mean that n equals 1. That's what we've been doing every single time until today. Semi-annually means that you're cutting the year up into halves. So that's basically what we dealt with in this problem. We took every year and we cut it in half. Quarterly, as we just saw, means n equals 4. Monthly is going to mean 12 because there are 12 months in a year. There are 52 weeks in a year. And there are 365 days in most years. So we'll say n equals 365 if we're referring to a daily amount of compounded interest. All right? So there's a breakdown of today's notes. So even if you weren't here, you should be able to do tonight's homework and pick up with us tomorrow. Have a good night, guys. See y'all tomorrow.